Okay, so I would like to welcome you to the webinar about BigQuery as a unified AI-ready data platform. Sorry, about the BigQuery as a unified AI-ready data platform. So, not sure how many of you have watched Next in Las Vegas, where Google announced a lot of the new stuff. But basically, if you have, you might have heard that they labeled BigQuery as a unified AI-ready data platform multiple times. Now, the question really is, what does it mean, right? Because you can envision under this a lot of stuff. And so here on this webinar, we'll be talking about what exactly it means, what changes are coming to BigQuery, how it's no longer a data warehouse, but a much more sophisticated system, and what else you can achieve with BigQuery. So a very quick introduction of myself. Who am I? My name is Samuel Kožuch. I'm a data engineer with 7+ years of experience. I've worked in small startups, large corporations. I have many years of experience with both batch and streaming processing. My initial background is statistics and mathematics. So I also recently got into ML and AI. I have experience with multi-cloud, so both AWS, GCP, Snowflake, partly a bit of Databricks as well. And I'm 2 times Google certified, a data engineer and data architect. So that was acquired recently. All right, so the agenda for today will be very simple. It's basically 5 steps, and we'll be cranking up the intensity of the webinar as we go. So we'll start light. We'll talk about the history of BigQuery, what it was, how it started, what was the initial purpose. Then we're going to talk about what BigQuery is becoming, which is basically multiple data formats, support for multiple data formats, and multi-cloud. We'll talk about push for data discoverability, data governance, data quality. And afterwards, we'll dive deep a bit into technical stuff. So we'll talk about how you can query your data in BigQuery, not only using SQL, but also using remote functions, Python, PySpark, etc. And we'll also touch a bit about ML, AI, and ML ops on BigQuery with Vertex AI and other integrations. All right, so let's start with the brief history of BigQuery. So BigQuery initially was introduced, or was actually privately developed in 2010 by Google. So the initial purpose of BigQuery was to be used for analyzing the vast amount of data which were produced by internal Google services. So, for example, Google Ads, Google Analytics, YouTube, etc. In 2011, BigQuery went public. So initially, it was not integrated into GCP because GCP back then wasn't really a GCP. So it was a standalone product. As I mentioned, it was originally only meant for analyzing large amounts of data, and it did not have direct SQL support, or actually, it was a form of SQL, but it was not the SQL we know today. It was basically read and append only, so we didn't have any delete statements, update statements, stuff like that. Between 2015 and 2017, there was basically Google realized that they were onto something with BigQuery, so they started to really innovate with BigQuery. That's basically when the capacitor was introduced. So capacitor is the columnar format of BigQuery. BigQuery is a columnar database, so it stores data in this capacitor format. What it means is that basically each column in BigQuery is stored separately and is read separately. BigQuery does not have to decompress the data before reading the data. It can basically read uncompressed data, meaning that it saves the bandwidth, it saves the memory, and that's why it's very fast. In 2016, they also introduced the Google SQL, which is the SQL which we're using today. So that basically pushed BigQuery closer to a warehouse, as it finally had support for delete, update, insert statements, classic DML language. You could manage your tables, stuff like that. And basically 2018 and onwards, there's been a push for better usability, for better usage of better processing of large data. So basically, partitioning was introduced, UDFs were introduced, BigQuery ML was introduced, and also the BI engine, for example, was introduced, which is a huge help if you're connecting your BI tools to BigQuery. The basic structure of BigQuery, or actually the basic architecture of BigQuery, is very simple. It actually consists of 4 simple components. They are codenamed Dremel, Jupyter, Colossus, and Borg. So Dremel is the compute engine, basically. So that's what computes your queries when you publish any query to BigQuery. It is a distributed system, so what it does, it actually decomposes your query into a tree format and basically computes each leaf separately. So each leaf actually is, if you're familiar with BigQuery, you might have heard the term slot. So basically, actually, each leaf is 1 slot. And after the query is finished, it basically composes the results back together. The Jupyter is the network. So this is 1 petabyte per second network, which is used internally by Google. So that's why BigQuery is fast, because actually, what I forgot to mention is that BigQuery it has a separate compute and storage. So basically, the data is stored somewhere else somewhere else to where the compute is happening. So before computing the data, BigQuery has to read the data from the storage, and the fast readouts are possible because of the Jupyter. And then you have the Colossus, which is basically the distributed file system. So that's basically what BigQuery is running on, what the Google Cloud Storage is running on, etc. So enough with the boring stuff. Let's dive into the first thing. What's basically happening to BigQuery in the past years. So there has been a, I call it, disturbance in the force, because I like Star Wars. But basically, over the past 2 or 3 years, you might have become familiar, or you might have heard a term called lakehouse. So what is a lakehouse? Well, it's a combination of data warehouse and data lake. It basically tries to combine the best of both worlds between data lakes and data warehouses. In data warehouses, you usually only have support for structured data, but you have a very powerful compute. You can analyze your data with SQL. You have great governance, security of data, etc. On the other hand, with data lakes, you have cheap storage. It's very easily scalable. You have support for multiple data, not only structured, but you're using some form of governance. So lakehouse concept tries to combine the best of both worlds. You try to have the best, so cheap storage and scalability from data lakes, plus powerful processing engine from data warehouses and governance on top. The primary purpose of lakehouse is also to get your business ready for analytics and AI use cases. So warehouses in general are good for ML, but they are not the best. So let's, for example, say that you want to analyze pictures or audio. So it wouldn't be an easy task in the warehouse itself. So Google developed a BigLake, which is a storage engine of sorts, a translation layer, if you will, which helps you basically translate the files from any storage to any product in Google Cloud. What it actually looks like in practice is something like this. So you have the BigLake layer on top, and BigLake can connect to any supported storage solution where you store your data. So for example, it can be BigQuery tables, right? So in BigQuery, we already have structured and unstructured data. But apologies, if you want to have unstructured data as well, you can connect BigLake to a Google Cloud Storage, or even S3 or AWS or Azure Blob Storage. The advantage of BigLake is that it essentially doesn't care where your data sits. It makes it available to other cloud products. So you do not, you do not need to, for example, write parsers or parse the data or load the data to BigQuery, etc. You put a big leg on top of it, and basically you can query data in a single unified interface. As I mentioned, BigQuery also supports S3 and Azure Blob, so it's not only limited to GCP. And with BigQuery Omni, you can actually also query the data in S3 and Azure Blob Storage. So BigQuery can sit on top of the data, and you can query your data in GCP with data in AWS S3 or Azure Blob Storage together. If you see here, this green bar here, it's not properly or very well visible, but it's written here Dataplex. So you might be wondering, like, why, like where does it sit? Is it like a new product? Like, how can I use it? So the thing is that you cannot see it. It's basically hidden under the hidden under the hood, but you can basically integrate it with Dataplex, and very greatly integrates with Dataplex, and it allows you to basically discover and govern the data. So as I mentioned, where is the big lake, right? It's under the hood, it's hidden, it integrates with Dataplex. Using Dataplex, you can basically manage the lakes, the zones, the data assets. So we can tell via Dataplex that my data is expected to be here. And Dataplex or BigQuery can basically run auto discovery of the data. What BigQuery does is that when it discovers data in, for example, cloud storage, it automatically makes this data available in BigQuery. It doesn't copy over the data. Instead, it creates a link to the data from BigQuery to Google Cloud Storage. So when you're basically, this makes these tables available in BigQuery, and when you try to query these tables, you're not actually querying the data in BigQuery, you're querying the data in cloud storage. Advantages of having this integrated with BigQuery is that you also have data quality, lineage, profiling, security from a single place, stuff like that. So very quick demo. I'm going to jump into the Cloud Console just to show you what it looks like. So this is, if you're not familiar, this is what Dataplex looks like. Basically, this is this here is a data catalog, and in Dataplex directly, I can manage my lakes, my zones, my assets, right? So I created here 3 lakes actually. Let's go to sales lake, where I have 4 zones. So in each zone, I actually instructed Dataplex to look for certain data, right? So for example, here in the bike lending zone, I told Dataplex to look at one of the buckets which I've created, which I'm going to show you, and to look for any data that might lend there and make this data available in BigQuery. So this is, for example, the first bucket which I created. So I have here the bike trips. The BigQuery basically offers you support for various open source formats such as Parquet, Apache Iceberg, Delta Lake, CSV, Avro, etc. So you can have your data in any format you want. So for example, here I have my data in Parquet format, which is Hive partitioned. I have also the stations table. So the first one was the bike trips. I also have the stations table, which is the simple CSV. And I instructed Dataplex to look for the data. And what Dataplex does, or what BigQuery does, is that it brings this data directly to BigQuery. So I have here my zones, which I created in Dataplex. And as you can see here, like, it made available both the bike trips and the bike stations available. You can query this data, or actually, if I show you this data, this is just a standard table with a BigQuery label on it. So you can see the schema, you can see the lineage, you can still see the profile, etc. You can query the data as if it was the normal regular BigQuery table, but actually what you're querying is the data in cloud storage. The same goes for unstructured data. So for example, for my unstructured data, I created another bucket, and I also basically created a zone in Dataplex. I told Dataplex to look for the data there. Here I have basically 2 folders, which is audio and images. In audio, I have a recording of Game of Thrones episode, or sorry, review of Game of Thrones episode. And in images, I have 3D images of cat, dog, and JPEG. So what BigLake does, as you know, it also supports structured and unstructured data. So it brings it to BigQuery as a object table, right? This is the lakehouse approach that BigLake is pushing. So your data is, no matter whether it's structured or unstructured, it's available in BigQuery for querying. So you might be wondering, what does it actually look like if I want to query images? Well, it's actually nothing more than basically a link to that file, right? So for example, for my images, I have here the URI, I have the MD5 hash, the size, etc., and it's the same for the audio. And this unlocks many new use cases because it allows you to push this data to somewhere else, which we'll talk about later. But basically, you can push it to an AI algorithm, to Gemini, for example, to speech to text, etc. And you can work with unstructured data directly in BigQuery. All right, so let me actually show you one more thing, which is the data quality and lineage, which I'm going to touch on just very quickly. So as I mentioned, the Dataplex or BigLake integrates with Dataplex, and since BigLake tables are actually the normal tables, you can see the stuff like lineage, the profile of each table. You even can set up data quality data quality tests. So here, for example, set up the uniqueness for primary key. It's very important in the age of AI to have data which has quality, which doesn't contain any duplicates and stuff like that. So this BigLake integration with Dataplex allows you to basically combine two in one, because you have quality data and you have data from many sources. Okay, let me jump back. Now we're going to go into more technical stuff. The third or the fourth fourth big point, which I would like to touch on, is that BigQuery, since it's becoming a lakehouse, you not only need SQL to analyze your data, and you no longer need to process your data only in BigQuery, right? So BigLake serving as that translation layer really helps, and you no longer have to just process data using standard SQL statements, but for example, you can utilize any other language. So what does it really mean, right? Does it mean that SQL is dying or it will not be used in BigQuery? Definitely no. I mean, people have been predicting that SQL will die in like 90s, 2000s, 2010s, 2020s, etc. So SQL has been dying for 50 years, according to people. I don't think it's going to happen. I think SQL is here to stay because there is really no great replacement for it. But what this means is that you're no longer required to know SQL in order to analyze your data in BigQuery. If you've heard of other programming languages like Python, Spark, Java, etc., you now can use these languages to basically analyze your data, or to write functions which help you analyze your data. You can also utilize remote functions, which help you, for example, communicate with external resources directly within your SQL query. And also, you can utilize natural language to process your data. So we're going to touch up on all three of these. Let's start with the first one, which is the big frames. So as I touched upon already, there's a new champion which entered the block called Big Frames. So this is another library. Before we had the BigQuery SDK, but to be honest, if you are a data scientist and you try to work with BigQuery SDK, you still required a knowledge of SQL, because basically what it did, you had to write your SQL query, which then got sent to BigQuery and basically executed the job there. Big Frames is different. Big Frames offers a pandas-like and scikit-learn-like APIs to interact with the data. your queries or your basically Python code gets translated to the SQL queries, right, for you. So you no longer require a knowledge of SQL. All you need is a knowledge of Python. You can, these basically your Python commands get directly translated to SQL, sent to BigQuery, and analyzed there. There is no local processing of data. So you don't have to basically do any analysis in your memory, right? So for example, as you can see from my screenshot here, this was done on a 35 gigabytes of table, right? So I would require at least, let's say, 40 gigabytes of RAM if I wanted to load this table in memory. But with big frames, what I can do is I can actually connect this table to the BigQuery engine, and execute this table, execute any SQL queries against this table via Python. So BigFrames is a Python library like any other. So it's not you can basically run it locally. You can run it in a hosting notebook, in a Jupyter notebook. Since it's a notebook, you can version control it, etc. So a quick demo of what it looks like is that let me jump into one of the notebooks. So first improvement, like I'm going to do this in a hosted notebook in BigQuery directly. So what it looks like actually, if you click the plus button here, apologies, if you click down arrow next to the plus button, you can now query your data using Python notebook, right? So I have some notebooks prepared here, which I'm going to show you, and this is basically what it looks like, right? So I have my BigFrames library, I specify some project, my region, etc., and I specify which data set I want to read. So when I basically read, or when I execute this code gets translated to a BigQuery job, which you can see here. Basically, it gives me a log of all the jobs, and gets executed in BigQuery. BigQuery then returns the results to BigFrames, and BigFrames basically shows you these results. So this is huge. Like if you have terabytes or petabytes of data, and you need your data scientist to work on the data, because you no longer need to have like huge machines available to process the data. BigFrames is, as I mentioned, it's not only Pandas API, but it's also scikit-learn. So it has like the train test. You can use the train test splits. You can use feature engineering, such as one-hot encoding and stuff like that. And you can even train the models, which we're going to touch up a bit later on. But basically, it's become like the full Pythonic way to communicate with BigQuery. So we no longer need that SQL. Another thing which is quite huge and underrated, and many people don't know about it, is that you can execute remote code with BigQuery. So you can directly connect to Cloud Run and Cloud Functions from BigQuery. What it means for you is that you can basically use any supported languages that are supported by Cloud Run or Cloud Functions. So for example, for Cloud Run, since it's a containerized application, you can basically plug in any container, right? So that means for you any language support. Utilizing this connection between the Cloud Run, Cloud Functions, and BigQuery, you can connect to external APIs. So for example, let's say you need to send the data to external API to enrich the data. You can do so using BigQuery remote functions. But you might be wondering, like, hey, is this any complicated? Because this it seems like quite an overhead that you have here. But really, it's not. Basically, from your end, what you need to do is you need to deploy your Cloud Function. You need to create a connection between BigQuery and the Cloud Function, and that's it. BigQuery takes care of the rest. You can reference your remote functions directly in the code itself, in the SQL code or in the BigFrames code as well. So there's no special queries needed. Basically, this is still a SQL query that you're running against BigQuery. What it looks like is, let me maybe open it here. Apologies, I don't have this ready, but I created a a cloud function. So let me actually jump in here. I create a cloud function in Cloud Functions, which basically has some code which executes. In my case, it's a simple it's a simple bucket which basically returns above 100 for 4,000 or below 4,000, right? So a very simple cloud function. I created then a link to that cloud function from BigQuery. So this is basically done with a remote connection. So basically all you need to do is specify an endpoint and specify the name of your name of your function in SQL. And you can then call this cloud function directly from your SQL. So for example, if I run this, you will see that it returns a very simple below 4,000 bucket. So behind the scenes, BigQuery is calling this cloud function with the data that you provided. It doesn't have to be a scalar data. You can provide, for example, column data as well. So if I had a table, I can provide the full column of the data, right? The same then can be achieved in big frames, for example. So let me just scroll here, for example. With big frames, you can either basically deploy the function by using the remote function decorator. In that case, big frames does it automatically for you, so it deploys as a cloud function, and then that cloud function is available for querying. And you can then, for example, apply that cloud function to your big frame data, right? So for example, you can see here that before I did not have any column about the bucket, but when I applied my function, I suddenly have the column with the bucket. You can, of course, read the remote cloud functions. You can create, manage everything from big frames and BigQuery ML. So this unlocks a lot of possibilities when it comes to connecting with external sources, when you have code which is too complicated, for example, to be done in SQL only. And the third new way how you can manage your data, or how you can basically analyze your data, is with no programming at all, using just your natural language. So Gemini has been released over a year ago, and of course, Gemini has been deeply integrated into everything GCP. And it also brought us some great features when it comes to BigQuery and the notebooks and stuff like that. And that is the integration of Gemini and basically usage of natural language to process your data, right? So in BigQuery, we have data canvases, but which I'm going to show you, but you can also utilize it in a notebook, for example. So let me first start with a notebook. For example, you can see here that I have here a generative AI, and I can, for example, just say that, hey, install BigFrames library. So basically, behind the scenes, what it does is it connects to a Gemini. Gemini translates the code and provides the code, and then I have to execute it. Data canvas is the second option that you can do. So this is actually what it looks like. It is a visual natural language processing or exploiter analysis of your data. How it works is basically you choose any data you want, and you basically give Gemini a prompt, right? So for example, here I have number of trips per start station on my bike data. Gemini then generates a query. It provides me with the query. I have to run the query manually if I want, so I can double check it. So here, for example, I'm satisfied with the query. I can double check it, and I get the results. You can not only explore the data, but you can also visualize the data, right? So this one is kind of messy, but for example, this bar chart here gives me a great idea of how many trips per day of the week I had, right? And if you want to explore further, very easy to, for example, query these results, and basically it creates a new branch, and I can utilize my prompt. So BigQuery now offers many new ways how to work with the data. It's no longer just SQL. It's now a PySpark, it's a Python, basically any programming language you want, plus the natural language with integration of Gemini. And finally, where does BigQuery stand when it comes to ML, AI, and MLOps? So this is quite a convoluted topic. So I will try to give you a brief rundown of everything. But basically, there are multiple possibilities how to do AI in BigQuery. This is, by the way, my favorite meme. usually it's not as simple as these memes make it look, as we can basically see here, because like you also have multiple options how to work with the data. So you have in BigQuery directly, you can, for example, utilize the Cloud AI models. You can train your own models using the BigQuery ML, or you can have models in Vertex AI that you can bring to BigQuery, or you can combine all of the above. So this seems like a mess, and I promise you it looks like a mess, but it's not a mess. So let me start with Cloud AI. So Cloud AI is the first of 3 options of the models you can use in BigQuery. So these are pre-trained models which you have basically no control over. These are pre-trained models that Google offers you. They are state-of-the-art. So for example, Cloud AI has vision, text-to-speech, speech-to-text, generating text, stuff like that. You don't have to take care about any training with Cloud AI models. You just basically plug the Cloud AI model into your SQL query, into your Python, and it can do stuff for you. Then you have the BQML. So BQML is the BigQuery ML. This allows for training of your own models with tuning, with batch predictions. You have pipelines, you have notebooks on orchestrations. But what you don't have is ML ops. So you cannot productionalize these models. You cannot deploy them to an endpoint. You cannot have online predictions. This is where Vertex AI comes in. Vertex AI can do everything. Vertex AI is a one-stop shop for AI, basically. And the great thing which has happened over the past year is that you can bring BigQuery ML models to Vertex AI. What it means is that you can train models directly in BigQuery without your data leaving anywhere, without having to plug any connectors, etc. And you can then bring them to Vertex AI and deploy them to production, deploy them to an endpoint, version them, evaluate them, etc. On the other hand, there's also a support of Vertex AI models in BigQuery, so the other way around. What it means is that you can, for example, train more models in Vertex AI, deploy them to an endpoint, and create a connection to that endpoint within BigQuery. And again, utilize within your SQL query to predict, basically, using those models. So let's check out how it looks like. Let me first jump into the Cloud AI. So if you remember that audio and pictures data frame which I had for you, I didn't actually create them just to show you that BigQuery supports it, but I wanted to also show you what it looks like if you want to analyze that data with Cloud AI, right? So if you remember my images table, what it looks like is basically just a picture of a cat, dog, and a Formula One, right? So what I can do is I can utilize the ML annotate image. Annotate image actually connects to Cloud AI Vision, and I have here my Cloud AI model, which I basically just connected using the GCP connection. So this is very simple setup with the connection. It's literally 2 clicks, and you're all set up. And what I can do, I can send data directly from BigQuery to Cloud AI Vision. What it returns is exactly what I asked it to, right? So I asked it to identify what features are or what labels are present in the image, right? So for example, creating exactly like cat, there is a plant with a dog on it, or dog with a plant. There's a tire for the F1, right? So this is great that basically any, you can analyze unstructured data with AI directly within BigQuery. So BigQuery is no longer just a data warehouse. You can do the same for audio, for example, right? So that audio file, which I had, the 1-minute review of a Game of Thrones episode, I can send it to the speech to text. So I'm not going to run this because this took about a minute to process, but I have prepared here what the output looks like. So the output looks something like this. So it gives you the full transcript of what is going on in that audio file. You can also create the models the BigQuery ML way. So that's the second way. So either there is a SQL query for creating the BigQML models, for example, something like this, right? So for example, create or replace model, where I specify what type of model I want, etc., etc. But to be honest, I find this pretty cumbersome because let's just say that defining models in SQL, it's not very natural. So you can do this in big frames as well, right? So for example, here after some pre-processing, apologies here. After some pre-processing and one-hot encoding and whatnot, I split my data into train and test, and directly in Python, I basically trained a linear regression. Again, big frames, it doesn't execute locally. It executes literally everything in BigQuery. So this query got translated to a BigQuery ML job, and everything, the whole training, the whole evaluation and stuff like that, got trained in BigQuery. Then from big frames, I can, for example, export that model to BigQuery, or I can register it in Vertex AI. So this is where that third point comes in, which is basically having BigQuery models in Vertex AI. What it looks is, apologies, your models directly from BigQuery will show in Vertex AI. Right, so I exported my model in BigQuery as a Penguins Lin Rec, I believe it's called. Yes, Penguins Lin Rec, and so I can see here that, for example, my Penguins Lin Rec model is now available in Vertex AI. So what I can do with Vertex AI is I can compare versions, right? You can compare the versions 2, 3, whatever, like what changes happens, right? So Vertex AI is the full stop, one-stop shop for all AI. Moreover, I can take this model and I can deploy it online for online predictions, because as we spoke, BigQuery has a major limitation that these trained models in BigQuery ML are only for batch predictions. So if you want any online predictions, you need to deploy to Vertex. And this is very simple because BigQML, since it's integrating with Vertex AI, you can literally take your model from BigQML and deploy it in Vertex AI. And of course, it goes the other way around. So you can have Vertex AI models integrated within BigQuery. One good example of this is, for example, Gemini, because Gemini is a model which is present in Vertex AI, but it's not. I mean, the LLM itself is not present in BigQuery, right? You have Gemini present in like UI and everything, but not in the SQL code itself. But what you can do is basically do the opposite. You can, for example, create a connection between the Gemini in Vertex AI and SQL, and then you can basically use your Gemini in the SQL query, right? So, for example, here I'm saying hello to Gemini, and you can see it responded in a JSON format, and I can work with that response. Or, for example, what I can do is I can take my audio file, which I transcribed, that episode of Game of Thrones, and I can tell Gemini to summarize it, all within the SQL, all within BigQuery. You can basically do the same in big frames or any other language of your choice. So, just to sum up, we're nearing the end, and we'll have a Q&A afterwards. What's happened to BigQuery, really? You may remember as a warehouse. It no longer is a warehouse. It's become more of a Google calls it unified data platform. It indeed is a data platform because you have support for structured, unstructured data, for open source formats such as Iceberg, Parquet, Avro, CSV, JSON. You have multi-cloud support, both for AWS, for Azure Blob Storage. With BigQuery Omni, you can query the data in BigQuery. You no longer require SQL to query the data, right? You can utilize pretty much any language you want with the remote functions or with Python, with PySpark procedures, with big frames. And of course, it's AI ready because it integrates. First of all, it has the ML AI capabilities built in, but at the same time, it integrates greatly with Vertex AI, where you can productionalize your models. And that is pretty much it. So if you have any questions, or actually, I might go into the Q&A itself. Apologies, and see if you have any questions. Okay, so what are the advantages of having structured data in data warehouse versus data lakehouse? Depends. I would call, I mean, the structured data. So if you integrate, for example, BigQuery as a lakehouse, you still have an option to basically use BigQuery as a warehouse. So you don't have to store the data in cloud storage, but you can still store data in BigQuery. So if you, for example, use the BigQuery as a lakehouse, like it's still a warehouse. But like if you're talking about just a plain basically just storing data in cloud storage instead of BigQuery, usually there are no direct advantages. Like if you don't want to have support for unstructured data, usually it's simpler to just go with data warehouse, because first of all, it's probably going to be faster. At the same time, you don't have to manage like lakes, lake zones, assets, and stuff like that. So what's really magical about the BigQuery and the whole Dataplex Big Lake is that you can start with the data warehouse, and with one click, you can migrate from BigQuery warehouse to a BigQuery lakehouse. So it really depends on the use case, I would say. Like if it's just plain structured data, I would go with the warehouse because it's faster. If you want both like open source formats and structured data as well, then I would probably opt in for lakehouse. So in order to work with ML models, what kind of data science expertise is required? Again, depends. If you want to utilize, for example, the cloud AI models, which are pre-trained and you basically don't have to do anything, then basically no experience is required. From your end, you just plug into those models and you basically utilize them in BigQuery. When it comes to training your own models, here's where it gets a bit tricky because you have many models. Some are complicated, some are simple. I would say when it comes to stuff like linear regression, logistic regression, and stuff like that, you can find thousands of tutorials online on like what to do, what not to do, right? So those simplest models are very simple to learn. When it comes to more complicated stuff, like for example, boosted trees and stuff like that, that's something that you really need experience with, and ideally, that's something that the data scientist should do. Usually data engineers don't get involved in this because when it comes to like tuning and tuning the models and like validating the models, like, etc., that's basically the whole different area of expertise, and that's something where data engineers and data scientists differ, right? So data engineers usually focus on ML ops, not really training those models, but productionizing those models, using them in your queries. Data scientists then focus on basically training, tuning those models, and like working with the actual ML. All right. Are there any questions which are not posted in Q&A? You don't have to be shy.
And you can now unmute yourself and talk directly.
Yes, you don't have to post in Q&A. You can unmute and talk directly. Exactly. No? All right.
Hi. Yeah. Just one question regarding BQML.
Yeah.
So BQML models, like we don't need any expert coding language, right? So we just need to know the basic data science thing to work on BQML models, right? So what kind of things are needed to work on BQML models?
Well, it's so BigQuery models, like they can be managed. They can be like auto ML models as well, or they can be non-auto ML models. So auto ML models, what it means is that like, hey, you can tell BigQuery to basically do the best job it can, and like it will do it itself. So basically the only experience it requires knowing how to write queries or knowing how to create a model in BigQuery, right? When it comes to like training your own models and tuning your own models without AutoML, like there are multiple strategies. Like you have it's probably best to talk with data scientists on this, but like you have optimization strategies such as gradient descent and stuff like that. So that's another conversation for 30 minutes. But don't get me wrong, like BigQuery ML requires some knowledge if you're not using AutoML, some knowledge of data science, because it's still trying to give you the best performance it can. It's not only it's not like the models are everything, like always the best. It still requires some sort of tuning or some sort of evaluation, like that your models are correct and giving you correct results. Does that make sense?
Yeah, yes, sir. Okay, thank you.
Okay, any more questions? I see there's one here. So if you understand correctly, BigQuery is in Jupyter notebooks. How much does it differ to Databricks? The answer is not much. No, Databricks has been viewed as a disruptor when it comes to the lakehouse, because it's basically the first lakehouse really, which came, or first platform which came with the lakehouse concept. Ever since then, like everything has tried to basically be the same. So the Jupyter notebooks directly in BigQuery, like how they work is you have it actually creates a Vertex AI workbench. So basically that's a VM. You can specify your VM, you can spec it, or you can use the default one. So it's some form of VM on which the notebook runs. And then if you're using big frames, essentially the only thing that's happening is that data is translated to a SQL query and processed in BigQuery rather in memory. So the whole thing is very very similar. It's not exactly one-to-one, but like the approach. I mean, the approach is built different, right? Because Databricks was built, let's just say, from scratch pretty recently, I would say. All GCP basically products have been here for a while, so it's not exactly one-to-one on how they integrate, but it's pretty similar. Okay, any more questions?
Samuel, like you spoke about this data catalog and Dataplex, right?
Yeah.
So data catalog and data dictionary, are they one and the same, or so if I want to maintain a data dictionary for our company, like so can we use Dataplex for that, or?
Yeah, exactly. So basically, if I jump back into Dataplex, you have here the search, and what it looks like is basically you have here the tables which I have here, right? So I can, for example, open one of the tables. You can see here the schema. I don't have the description and stuff like that, but you can see the schema, you can see the lineage, you can see I chose the wrong table because this one does not have anything, but if I choose this one definitely does, right? So you can see the schema, you can see the lineage, like up to the cloud storage, basically. You can see the profile, the quality. Also, there is, of course, the glossaries, the attributes, and at the same time, you can secure the data, right? So, for example, if I want, you can use tags to secure the data, to give access to somebody. Or, for example, I can go here to secure, and I can, for example, say that, hey, these are the people that have access, and I want some other people to have access to this zone or to this data, this asset, etc. So Dataplex is not only a catalog, it's also lineage, quality, governance, security. Basically, it's all in one. Plus, it's the one thing that basically integrates with, it's basically a front end for BigLake, if I may say it like that.
Yeah, okay.
All right, any more questions? Some ways Microsoft Fabric similar to BigQuery. Yes and no. So Microsoft Fabric is if you combine basically Vertex AI, BigQuery, and Dataplex, you get Microsoft Fabric. So BigQuery is just part of Fabric. Fabric is like a convoluted stuff like where you can run notebooks and AI models and stuff like that. Here you get it in basically 3 products which are bundled together, and that's what basically I would call a competitor of Fabric.
Okay, so each product is being paid separately, right? As it was with Azure services.
Yes, exactly. So basically you paid separately for storage, for compute, and then for Vertex, for AI.
Thanks.
All right. If there are no more questions, I would like to thank you for attending. We're only 8 minutes over time, but it's usually been due to questions. So we might have more webinars to follow. So please make sure to follow us on LinkedIn if you're interested. We're definitely looking forward to, if you have any topics you would like us to cover, feel free to reach out and we can talk about them in the future. Recording will be shared. Next session because Dataform. I recently started to play with Dataform as well, so I can do a session on that for sure. Yes, so recording will be shared after the session, either via email or LinkedIn. So look forward to that. And with that said, I would like to thank you and enjoy your day.